In this video, we are quickly learning how to design a road with Civil 3D software. In this, we are using Civil 3D 2020 version, and it is the metric version I have opened. If you have 2020 or any other version, open the version in the metric unit desktop shortcut icon. So first of all, I will start a new drawing with a new template. To do that, I go here, application menu browser, new, and I will select Autodesk Civil 3D Metric NCS template. This is the template we are using to design our road. Now you can save the drawing if you want with the file name you would like. Next thing we do is we are going to import points into this drawing. To do that, you go to Home tab, Points, go to Point Creation Tools, and go to Import Points button, and it will have a small window like this. In that window, click this plus sign, and you have to go to the Civil 3D file in your machine. Usually this file is located in local disk C drive, program files, Autodesk, AutoCAD 2020. In your case, if you have any other version, you have to use that version. C3D Help Civil Tutorials. There you have to select the file type as txt and go to existing ground points, and it will be PENZD format. So I select this one and click open. Then here you have to specify the file format. It is PENZD file format. Then you have to add these points to a point group. I click this check mark here, and I click here to give a name for the point group. We say is EG surface points, and click OK and click OK again. So after few seconds, your points will be imported into this drawing. To see the points, you type Z in your command line to zoom and press enter. Then type E or select extend here, so that it will zoom extend into the imported points. Now you can see the points are imported into this drawing. So if you zoom to a point, it will give you the point details. So this is, if I select this point, this is the point number, this is the point elevation, and this is the point description. So this GRND means usually we call it ground. So this you have several point names, and you have several point numbers and point elevation. So if you want to hide the point label, or these are called point labels, and this is called the point style. If you want to hide the point labels, you have to go to point groups here in your prospector tab, point groups, right click, properties, and make sure your point label style is set to none, and click OK. Then all the point labels will be disappeared. Now this is how to turn off the labels. Now your screen looks much better. So I will click this in create points small window toolbar also. Now I am going to create a surface from these files. To do that, I go to prospector, surfaces here, right click, create surfaces. Make sure your surface type is thin surface, and surface layer will be C-topo. This is default. We say the surface name is EG. Just click your mouse here and type EG. And if you like to have a description, you can give it as existing ground. And I will take the default values here for style and render material. I click OK. Only we have created the surface name here. Now you have the EG only surface name. Now we are going to add these points to this surface. To do that, I click this plus sign here and go to definition and click that plus sign also to expand it, and go to point groups and right click here and add, and we will add the EG surface points where we have imported the points, that is the point group we have imported. This all points means all the points in the drawing. Currently these both these 2 point groups have same number of points, but if you add any additional points, the points will be gone to all points groups, but EG surface point group will hold the points we imported from the file. So I will click this EG surface points and click OK. So you will see now our surface is created. You can see these are the contours in this surface. You call it surface style. So if you want to change the style, we click here and go to surface properties from here, or else you can right click and go to surface properties, and from there you have to go to information tab and you can change the surface style. Let us say we will do something like this and click apply. You will see the style changes. You will see now the style changes. So we will for the moment apply border only surface style and apply, then click OK. Next I will do something called adding break lines. Before adding break lines, we will view the surface through object viewer. To do that, we will select the surface like here and go to object viewer from here. Otherwise you can right click and go to object viewer, and you can see there's a nice looking dam like high embankment here, and we have a kind of another small road here. So that is how it looks like in this drawing. So I will click close here. Then what I am doing is I will create a small road from here to here, because in this area we don't have points. Even though we have the surface here, we don't have any points here. So the surface in this area is not that accurate. So what I do is now I will create a manual boundary around this surface and add that boundary to the surface. So before doing that, I will select the surface and go to surface properties and set the style as no display and click OK. Now I am going to add a boundary manually to this surface. Before that, I need to create a manual boundary around the points. To do that, we will create a new layer for the boundary. I will type LA in my command line and I will get the layer manager. Once I press enter, it will give me the layer manager. Then I will select this 0 layer and press enter. It will give me a new copy of that layer. I will type it as boundary. I will type it as surface boundary, and I will select the color of that layer as yellow, and I will double click here to make that the current layer, and I'll close it. And you can see my current layer is surface boundary. In the command line, now I will type PL to create a polyline and press enter. Now I will create a polyline outside these surface, outside these points, but closer to the points. Like this. I will if you think this is out wrong by too much, I will press Ctrl Z to undo that point. Again I will click somewhere here to make that correction, and when I come close to the end, I will press C or select close here to close the polygon. Now we have created the polyline boundary around the points. Now I go to prospector, expand EG and expand surface, expand EG, and go to definition and go to boundaries, right click, add, and I will type it as boundary and click OK, and I will select this boundary and it will give me a new boundary to the surface. Now to view the surface boundary, I will select the surface EG here, right click, go to surface properties and select the border only style and click apply. Now you can see our boundary is modified, not like before. So I will click OK now. So I don't want the boundary, the manually created boundary, but you can't delete it. If you delete it, the surface will be asking to rebuild because you don't have the boundary anymore. So we have to freeze this surface to make it hide inside the drawing. So I will select the polyline and go to surface boundary layer and select here freeze. Currently it is saying it is the current layer, you can't freeze it. So I will press layer manager here and I will go to 0 layer and make it current layer and select this one and go to turn off that layer. Now we have only the surface here. Now in here I will do object view. I will view the surface through object viewer. Now this time you will see the surface much more less area, because initially the surface was in this area also. Now you can see it is in a less detailed area, less extent but more accurate surface. So I'll press escape to exit the object viewer. Now I am going to create a road from here to here. So we call it creating an alignment. So to do that, I will go to Home tab, Alignment here, Alignment Creation Tools, and my alignment name is, let us say, Road Center Line, and your alignment style would be proposed. We'll say alignment style is layout and alignment label set is all labels. I'll click OK. Now it will give me a small toolbar to draw your road. So I will quickly draw a road here. I will click this corner and using this drop down I will go to tangent, no curves. So it is asking to select a start point. So select your start point somewhere here. If you have turned on your object snaps, press F3 key on your keyboard so that your object snaps are off. So I will click here, somewhere here, let's say somewhere here, and I will start my road from here. So I will stop my road somewhere here. I will click here and come to this point and click here. So I have a 90-degree bend here. So once you stop drawing, right click on your mouse button to stop the road. Now you can see our road is drawn. Now these are the labels. This is 0, this is 20 meter, 40, 60. This is the length of the road in terms of stations or chain edges. Now this is a 90-degree bend, so usually you should have a curve here. So now we are going to add the curve here. So to add curves, you go here and go to free curve fillet between two entities radius. We'll go select this option and it is asking to select the first entity. So select this red color area, red color line, first entity, and the next entity means the other side red color line. Then it is asking what is the curve solution. It should be less than 180 and press enter. Then it is asking the radius. Let us say the radius is 100 meters and I'll type enter here. So we will press enter here, and it will give us a curve here. Then right click to end the creation of curves. Now you can see your stationing is numbered along the curve. Now we have created our alignment. Next we will create a surface profile and profile view to our alignment. To do that, select the alignment here and go to surface profile, and you will have a road center line, your alignment name here and your surface name here. Click add here, it will add to the surface profiles, and go to draw in profile view. So in here you can go with some options, but we will directly create the profile view here. And now once we click create profile view, it is asking select profile view origin. So you have to select somewhere here to create the profile view. So your profile will be now created. In this, the profile view means the elevation of the surface along this alignment, that is called the surface profile. So this is the elevation of the ground along the alignment. You can see it here. So currently it seems like this is a bit confused because of this grid details. To modify the grids, you select this grid and go to profile view properties and go to this drop down and go to edit profile view style. You can right click and go to there also, and in the grid tab select clip vertical grid, clip highest profile, and clip horizontal clip, clip highest profile, and click OK. Now you can see a better view of the surface profile. Then what we do is we will create a new profile along this surface profile. So that will be the new road profile we are creating, or the elevation of the new road we are going to create. So I will close this toolbar. Then select your profile view. Select your profile view somewhere here, and go to profile creation tools from here. So it is asking for a profile name. Let us say final road profile, and these are your common values. You can use this layout option here also and click here. Now it is giving you a small toolbar to create the profile on your profile view. It is called profile layout tools. You go to here, draw tangents, and click here. First start catching the 0 point here. To do that, press shift key on your keyboard, then right click and select endpoint. You will get the endpoint here. Now you can start drawing your road like this. Just say we will be drawing our road like this, and finally we are doing the same thing. Shift right click and go to endpoint and select the endpoint of the profile, and right click to end the creation of profile. Now you have created the profile. So now we are going to add curves at these PVI points, because this is not smooth gradient transition, so we will be adding curves here. To do that, go to here and go to more free vertical curves, free vertical parabola PVI based, and select each PVI and type the PVI value curve length here as 100 meters. So it will give you 100 meter curve between those tangents. If you like to add more different curve lengths, you can add as you wish. So now I have finished adding. So I have gone to each PVI station and added those curves. After finishing everything, just right click to end the command. Now you will be given the labels of these points on the curve. So this is the curve length, this is the elevation, and this is the PVI station, like that. Now we have a small band tab here. In that band you can set the existing ground elevation and finished ground elevation. Currently both values are same, even though you see as two values, but both the values are same currently because it is given from the surface value. So I will select this profile view and go to profile view properties and go to bands tab here and move to the right, and your profile 1, that means this data will be given by EG surface, that is your existing ground surface. Profile 2 we will set to the finished ground surface over your if you profile 2, click here, final road profile. So this data will be given from the finished ground profile. Now click OK. Now you can see the data is different here. So this is existing ground detail, this is finished ground detail, and at the bottom you have the station values. Now we have created the alignment and profile. Next we will create the cross section. We will call it the typical cross section or assembly. To do that, to create that, go to Home tab, Assembly here, create assembly, and your, let us say simple, let us say that your road name is 2-lane road, and make sure your assembly type is undivided crown road, and just use this view edit with shading code set style and click OK. It is asking to place the assembly somewhere here. Click, it will place the assembly there. Now you have the assembly created. Now you have to create the lanes or cross section components of the road here. To do that, go to here, tool palettes, or else you can press Ctrl 3 to get it. I'll click here. Then from here move to lanes tab. If you can't see the lanes tab, click somewhere here, and from that you can go to lanes tab. So select lane super elevation AOR. Then sometimes you will be asked to select some properties, but straight away click this point twice, once and again on this line click. So you will have two sides of your road. Now press escape. Now we will set up the parameters here. Select both, select this side and go to sub-assembly properties. Now let us say that is your RHS lane, right side lane. Let us say lane RHS. Lane RHS, and go to parameters. Let us say our width is 3.5 and default slope is like, and we will accept the default parameters here, the layer values, and for the potential pivot we will set this to no and click OK and click OK again. Now we have created this side. Now we will select the other side and go to properties. We will say lane LHS, and left side lane width will be to 3.5, and we will not apply the potential pivot. Click OK and click OK. Again, now we have created 3.5 lanes, 2 lanes either side of the road. Then we will add a shoulder. To get that, go to shoulders tab here. I am coming from this tool palette, shoulders tab, go to shoulder extend all, and whatever the parameter get, you go here and click this top circle. So it will add the value to this side. Again, go to this side and select that one, it will add to the other side. Now press escape and select this side and go to sub-assembly properties and shoulder RHS and go to parameters. Your shoulder will be 1 meter and other parameters I am not going to change. Now I am going to the other side, sub-assembly properties, shoulder, LHS, parameters, 1 meter and click OK. So now we have selected the parameters and we have get the labels. So if you don't see this properly, you can change the scale from here, drawing scale. Let us say we will set it to 1:500. Then you will see much more clear. If it is not clear, we'll say to 1:200. It looks now better. And then we will add a daylight here. To do that, go to daylight tab. If you don't see daylight, go from here and go to daylight from here. Then you will go to daylight bench and select that. Click this end and click this end and press escape. For this one, go to sub-assembly properties. Let us say daylight RHS. We are not going to change any parameters here, and go to the other side. Daylight LHS and click OK. Now we have created the assembly or the cross section for our road. I'll close this toolbar also. Then I am going to create a corridor. Otherwise, I am going to create the road in along this alignment. To do that, go to Home tab, Corridor. From here, Corridor. Then let us say our corridor name is 2-lane road, and your alignment and profile will be alignment center line, and your profile would be the final road profile which we created, and the assembly is 2-lane road, and your target surface is set it as EG. I will tell what is meant by this one and click OK. So it will give you a window like this. Just press OK here. We are not doing anything, just pressing OK, and you the rebuild the corridor option. So it will rebuild your corridor. So now you can see your road is created. This is called the corridor, right? Now we have created the corridor. Next thing is we are going to create the section views. Before creating section views, you need to create the sample lines. To create the sample lines, go to Home tab, Sample Lines, and it is asking to select the alignment. You can select the alignment from here, otherwise you can press enter to select from a list. Only the alignment we have is road center line. We click OK. So it will give you a small window to create sample line data. We will get these default values, and make sure for EG this is existing, and 2-lane road make sure this is view edit with shading. View edit with shading and click OK. click OK again. So it will activate the sample line tools. From there you go to by range of stations. So we will create sample lines from start to end, both are true, and we will create the data from the center line 20 meter offset to the left and from the center line 20 meter offset to the right, and we will be having sample lines at 20 meter intervals. At range start, that means start station, we need a cross section or section view. At the end station we need a sample line actually. So we set it to true. So these sample lines will be used to create the section views or cross sections. These sample lines will gather the data from Civil 3D corridor to create the section views or cross sections. Now I click OK. So you will see the sample lines are created along the corridor. These blue color lines are called sample lines. Now I press Escape to end that sample line creation. You can see my sample lines are now nicely created. Then I am going to create the section views. To do that, I go here, Home tab, Section Views, create multiple section views. So it will give you a wizard here. First we don't have to change anything, just press next. And then in the next section, select this draft option, place sections in a grid model space, and click next again, and create section view finally. And it will create the section views once you select the specifier origin for the section views. So click somewhere here. So it will create the section views for you. Now you can see the section views are nicely created. So this is your road and this is your daylight line or the cut line. Now this is at below the ground, so it will go up to the ground as a cut line. Here also as a cut line. If you come to this point, it will go as a fill line here. If you go somewhere here, you can see it. So most of the places you have cut. So you can see you have cut in most places. Very few locations we have fill condition. Now, if you can remember, I set the target surface as EG. So that means when you come to this point, your this daylight is searching for the existing ground or the EG. That is what we are calling the target surface. If your EG is above this point, it will act as a cut. If it is below the surface, it will act as a fill like this. Now these are cut stations. This is a fill value. Both angles are 1:1. That is why we are getting 50%. So this is basically how to design a road from Civil 3D. This is not in detail, but just touching the key points. So if you want to get more idea about road designing with Civil 3D, you can follow the description link, or you can follow the video attached in this end of the section to learn more detail about road design with Civil 3D. Before winding up the session, we will use the drive option in Civil 3D to run a small video or run a small animation on your road. So we will use this drive option. We will select the alignment. So I will select the alignment here. So if you don't get this two options here, type selection cycling on your keyboard, selection, cycling, and press enter. Make sure your value is 2, and then when you select some point, you will have to select, you will give an option, you will be given an option to select multiple options if you have in that place. Here you have the corridor and alignment, so it will give us multiple options. I will select the alignment and go to drive option here. So it is asking for a profile view. I press enter and my profile will be final road profile. I click OK. So after some time it will give me a view of the road. So you can use play button here. Now your video is running, you can see the animations. Now these are fill situation, so it will gradually come on to cut situations with time. It is going through a cut situation, that is why you can't see the road, so it will going below the existing ground. Again, now you are coming to a fill situation. You can see here the fill surface. So when you have a cut situation, your existing ground comes to the top. So I will stop that one and click close here. So that is a basic video demonstration about road design with Civil 3D. You can learn more about these things following the related videos in my YouTube channel, or the course listed in the description of this video to get more idea about Civil 3D.